Let us continue with learning outcomes number 4, which is you need to identify the spectator ions in a reaction. So, question letter A, it is there that the question is about you need to identify the spectator ions in the reaction below. So, this is the lesson 4.2. You have here the chemical equation Na2CO3 plus FeCl2 produces FeCO3 plus 2NaCl. So the rules here is that you have to make sure if that equation is balanced or not. So if it is balanced, you can go directly in solving the problems. So in this case, it's very clear that there are things that you have to take. There are some errors here. Based from solubility rules, this is not aqueous, but instead it is insoluble. So that will be our precipitates. So if you're going to rewrite it again, so we can have Na2CO3 that is aqueous plus FeCl2 and that is aqueous produces FeCO3 that is solid plus 2NaCl. So we know, and that is aqueous. So we know already that these are our balanced chemical equation. Okay, so our focus only in identifying the spectator ions. You have to remember that spectator ions can be found any one of the product here, any one of the substances in the product. Now, how to know that that will be the source of our spectator ions? You have to take note that for the spectators to be identified properly, we have to look at on the product side that is aqueous. So the aqueous here is the NaCl. Okay, you have to take note of that. So meaning this aqueous is actually the source. You can say that that is the source of our what? Source of our spectator ions. Okay, so that is the main source of our spectator ions. Now, how about the other one? Let's say you have Fe2, FeCO3. What is that? What is the purpose of that? And remember, FeCO3 is actually solid. Now, once again, if it is solid, that is our precipitate. And that will be, if that is our precipitate, that could be the source of our, what? Our net ionic equation. Okay, net ionic equation. So the question here is actually you were asked to find out the spectator ions. Okay, now we discussed before during week number 3 the process in identifying the complete ionic, then the spectator ions and the net ionic. Okay, so here this is the easiest and the fastest way. Now, since this will be the source of your spectator ion, since it is aqueous, so you can write it here, 2NaCl. Now you just simply break down them into ions, and since this is aqueous, so you can break them down into ions, into individual ions. So this will be breaking down into Na, and that is plus. So how you know that this is an ion? There is already a charge. Okay, there is already a charge there, positive. So that is one ion. And the other one is it will break up into Cl minus. That is also an ion, so that could be our second ion. So it breaks up into Na and then Cl. All right, so, but do you think that that is a balance? No, because if you can see here, 2 times 1 Na, so you're going to place 2 there, and this 2 also for Cl. So you have 2 ions that is actually produced there. 2 Na plus and then 2 Cl minus. And this is our spectator ions. Okay, spectator ions. So if you want the same process that we discussed in week number 3, you can use that. But since you will be taking exam, this is the easiest way to identify the spectator ions, and other one is the net ionic. So let's say for the net ionic. Now, for example, in the net ionic equations, how to write the net ionic equation. So as I said, this is our focus of our net ionic because that is solid precipitate. So we will just simply write down there as our product, okay, FeCO3, copy, just copy everything. And that is our product here. So what is our reactant before the arrow? So the reactant must be placed before the arrow. So what are those substances? We have Fe, and then another one, we have a CO3. So these are the two substances that is actually considered to be our, what? Our reactant, okay? So let me check this one again. FeCO3S. Now, this is now considered to be your net ionic, but there is something, you miss something there. This should be expressed in charges. So Fe, it should be positive 2, and then CO3, that will be negative 2. And that makes our, what, complete net ionic equation. Okay, net ionic equation. Okay, so I hope you learned something. The very fast process. This is the fastest way to find the spectator ions and the net ionic equations. So the only thing that is lacking is just to write the complete ionic equations, and I will show you in the next example. You can pause the video here, try to solve, and then after that we will solve it together using the conventional way that we thought in week number 3. Okay, so that you can compare which is more easier, this first step or this first way, and then or in this second conventional way that we used in our week number 3 discussion. So try to pause the video and work on this. Okay, so as I told you, we will try to use the conventional way that we discussed during week number 3. So the first step is we need to write the complete ionic equation. Complete ionic equation. And the second one, we need to identify the spectator ions. And the third one, that is after you canceled out the spectator ions, you can already identify the remaining net ionic equation. Net ionic equation. Okay, so as what we said, all aqueous, you can actually break them down into individual ions. So these are aqueous, aqueous, aqueous. But for solid, or that is our precipitate, that we cannot break them down into ions. And also the first step is you must make sure if the equation is balanced or not. So looking at the equation, is it balanced? Yes, it is balanced. So we can start writing the complete ionic equation. So we will start here. So since this is aqueous, so we can break them down into Ba plus 2. You know, Ba is actually here. The 2 there is coming from the Ba. And then Cl is 1, so that is C plus. Don't forget to write aqueous. I can use color blue. Okay, I will use blue for easy. This one. All right. So again, Ba plus 2, or you can write 2 plus, and don't forget to write aqueous. And Cl, if you look at Cl there, Cl is actually, this 2 here is coming from the charge of your Ba. 1 here from Cl, so this is coming from Cl. So plus Cl minus 1, and that aqueous. And then, so we're done with that. So let's move on to K2SO4 because that is aqueous. Okay, K2SO4. So remember, this 2 is coming from SO4, that is minus 2. And then there's no subscript there because this is one ion. So that will be plus, how many K's here? So there are 2K, and then notice the charge of K is plus 1. And then don't forget to write aqueous. Plus the second one is, how many SO4? Only 1. So you just write SO4 minus 2, and that is aqueous. So we're done with this. Next, let's move on to the next step here in the product side. So this is solid. So are we going to break them down? No, as what is the rule says. So you just simply copy BaSO4 and just write solid. Don't forget that one. And then plus the last one, we need to break them down because this is aqueous. So we can break them down. Now this is 2 K, and that K is plus. And then this 2 here again, the 2 here is for the Cl. And what is the charge for Cl? Don't forget to write aqueous. Plus 2Cl minus, and then that is aqueous. All right. So we're done with that. We're done with both sides. So this is our complete ionic equation. Now, how to identify our spectator ions? Now, spectator ions can be identified if we have ions that can be found on the reactant side and also found on the product side. So we will try to figure it out that is the same, similar, that can be found on the reactant and the product. So I will highlight. So if you look at here, I can have similar ions if you can see here. All right, so let's try to have K plus 2K plus is found also on the product side. So that's the first candidate for our spectator ions. What else? If you can see here, Cl, there's something wrong. I forgot to put 2 here. If you go back to for the Cl. So Cl here, that is 2. So there are 2 Cl here. So that is also similar to the Cl on the product side, this one. You see that? Is there anything else? Nothing. So therefore, the one that I highlight, I will just copy that one. Those are our spectator ions. That will be 2Cl minus, aqueous, don't forget. And the other one is 2K plus aqueous. Okay, so those are spectator ions. Cancel them both. If you have that one, you have canceled them. And the remaining will be our what? Our net ionic. And what is our net ionic there? So we will change that. We have Ba plus 2 aqueous. And then we have also this one, the remaining, plus SO4 minus 2 aqueous produces BaSO4, and that is solid. Okay, so you have 2 ways in solving this kind of problem. So for skill number 4 or learning outcomes number 4, identifying spectator ions. So there are different ways. Either you will use letter B steps, or you will use letter A steps. So it's up to you. You have already an idea how to solve this problem very well. So you have a choice whether you want to use step letter A or step letter B. Okay, so let's move on to, let's try, for example, if you have this given multiple choice question. Now, the most important thing here is that you must know the solubility rules. Okay, so let's start. Which of the following will occur when the solution of CuSO4 and then BaCl2 are mixed? So we have 2 compounds that will be mixed. Okay, so we have CuSO4, and then we have BaCl2. So again, we will use inner, inner, outer, outer. So this is inner, inner, and then we have outer, outer. Okay, so once again, this is positive, negative, positive, negative. So meaning we're going to write positive first. So inner, inner, so that will be BaSO4, and then plus outer, outer. So positive first, so CuCl. And then take note, Cu is actually positive 2, so that will be 2 there, CuCl2. Now, the question, Mr., how to know that that will be our solid or aqueous? We will go back to our understanding about the solubility rules. Now, if you, let me go back to the solubility rules here. Now, BaSO4, the first element or the first compound that was produced is actually BaSO4. That's what we have here, BaSO4 plus CuCl2. Using these solubility rules, can you identify does BaSO4 soluble or insoluble? So BaSO4. So SO4 is there, and then there's a Ba. So it is under important exception. So meaning BaSO4 is really a soluble, so that is insoluble. So therefore, this is solid. Now, how about Cl? Cl, Ag, Hg, they are insoluble, but Co only, that is only metal, so that is soluble. So therefore, that is aqueous. Okay, so meaning, if you go back to our problem here, once again, BaSO4 is solid, and then CuCl2 is soluble, that is aqueous. So meaning, this will be your source, as I said a while ago. If it is solid, this will be the source of your net ionic equation. Net ionic, or meaning this is your precipitate. Okay, that is your precipitate. And how about this one here? This one, the CuCl2, and this CuCl2 are your spectator ions, as what we discussed, spectator ions, the source. So it can be Cu plus 2 and then Cl minus. Okay, so that will be our spectator ions. So let's start with the choices. Take note, our precipitate should be BaSO4. Okay, so if you look at there, just look at the precipitate BaSO4 here, CuCl2. So eliminate. Precipitate should be BaSO4, not Cu. So this is eliminate. Okay, we have this. All right, so that's probably our answer, but let's continue here. BaCl2. So of course we must find the precipitate BaSO4, and obviously no. So the correct answer will be letter C. Okay, so this is question number 1. Now, I hope you get it how to solve this problem. So let's move on. I will give you a time, all right? So you can try to solve number 2. Okay, you can pause the video and try to solve number 2. All right, I hope you choose letter E. Okay, I hope you choose letter E. Why is it letter E? So again, inner, so Mg plus Cl2. So inner, so it will produce what? MgSO4, and then outer. This is CnCl2, so that will be plus zinc chloride. So MgSO4, is it a precipitate, or is it solid or insoluble? So let's go back. Or ZnCl2, is it a precipitate or a solid or an aqueous? So let's go back here with the solubility rules. Okay, again, we will write the compound that was formed. That will be MgSO4 plus ZnCl2. Now SO4, okay, once again, if you go back here, if it is SO4, that is soluble, yes. Is there any element or ions that is actually paired that makes it insoluble? No. So therefore, this is soluble. So therefore, that is aqueous. Okay, next. How about ZnCl2? ZnCl, Cl is here. The exceptions Ag, Hg, and Pb. So, so this is not insoluble. This should be soluble. So therefore, that is aqueous. So both are aqueous. So we have already an idea how to solve this problem. So aqueous and then aqueous. So obviously, no solid formed. So if there's no solid formed, no precipitate will form. Okay, so that will be all for learning outcomes number 4. Identify the spectator ions in a reaction. So if you will be asked with the complete ionic equations, spectator ions, and the net ionic equations, so I'm expecting that you will be able to answer those questions. All right, so